Hello and welcome to a video on midsegments, and these are some examples of the types of problems that use the two properties of midsegments. The first property being that the midsegment, as we see right here, is parallel to the third side, so they're parallel to each other. And the second property being that the length of the midsegment is half of the length of the third side. So it looks like that midsegment is about half, and we're going to see how we're going to verify that. All right, so first, what is the slope of the midsegment of AB and the slope of side ST? So in order to show that they're parallel, we're going to have to find the slope of both. So the slope of AB, so let's say this, we're going to use M sub AB for slope of AB, just so we can fit it in this space. The slope of AB would be the change in y over the change in x. So it's negative 2 minus 0 over 3 minus 1. And that is negative 2 over 2 or negative 1. Okay, so then let's check the slope of ST. So the slope of ST is the change in y. So if we're looking at ST, we're just going to go negative 1 minus 3 over 6 minus 2, and that is negative 4 over positive 4, or negative 1. So the slopes are the same, meaning that the lines are parallel. All right, so what can you conclude? That they're parallel. How about we just say AB is parallel to ST. We don't need to do a lot of writing because we have no notation, some notation for that. All right, so what about AB? Now this, remember, AB without a bar means it's the distance or the length of AB. So we're going to do those off to the side here. The length of AB is the square root of the difference in the x's. So we're looking at AB now. So we're looking at the midsegment, and the difference in the x's from 1 to 3, just say 3 minus 1, squared, plus the difference in the y's, which would be negative 2 minus 0 squared. Okay, and that would be the square root of 2 squared, which is 4, plus negative 2 squared, which is also 4. They're added. That's the square root of 8. Not negative 8, it's the square root of 8. All right, what about the length of ST? So we'll do that. Here, ST is equal to the square root of, now we're looking at the S and the T, so the distance between the x's is 6 minus 2, and the distance between the y's is negative 1 minus 3, and that reduces to 4 squared. 4 squared is 16, plus another negative 4 squared is also 16. So plus 16, that's the square root of 32. Now we don't want to leave our answers like this because we want to always write our answers in simplest radical form. So this is the square root of 4 times the square root of 2, or 2 rad 2. And this is the square root of 16 times the square root of 2, or 4 rad 2. Okay, so we found both of them. So let's just say here that AB is 2 rad 2 and ST is 4 rad 2. Compare the lengths. Well, we would say here that it looks like ST is twice as big, right? So ST is twice as big, or long, let's just say long, as AB. Okay, let's look at an example that's not on the coordinate plane. So let's look at an example right here. So we're looking at a triangle, and because of the marks on the diagram, we know that Q is the midpoint of TS, and because of these marks here, we know that P is the midpoint of TU. So therefore, we know that QS is a midsegment. All right, now we're looking for, I said QS and I meant to say PQ, or QP. That is the midsegment, and we're looking for that length. Well, we know from what we just saw above that the midsegment is half the length of the third side. So very simply, these are easier without the coordinate plane, at least with no algebra. We know that PQ is 1/2 of 30. So PQ is 15. Once we know the rule, we can apply it. All right, let's look at another one. All right, here we want IK. We're given the midsegment. We're not looking for it this time. We're given the midsegment, and we're asked for the length of the third side, so it's going to be twice as big. That's it. So IK is 10. And let's do one more that has some algebra involved. All right, so here we know that the midsegment is here, JI, and that the longer side, or the third side, is here. So we know that that red segment, TV, is twice as long as JI. What does UT have to do with it? Honestly, it's just there to distract you, and you don't need to do anything with that one. What we know is that 2 times x minus 3, 2 of the x minus 3's, is equal to x plus 6. Right? So let's solve that. So we have 2x minus 6 just by distributing. So 2x minus 6 is equal to x plus 6. Finish solving that by subtracting x from both sides, adding 6 to both sides, and we get x equals 12. And the directions aren't clear here, but we're asked to find x, but let's still plug it in. Okay, so let's say this one would be 12 minus 3, which is 9. And this one would be 12 plus 6, which is 18. Well, 18 is twice as big as 9, so we must have done something right. Okay, I hope you found this video helpful.